Recorded is rolling. It is Tuesday, January 7th. You guys have your Geneva Drive projects. We did a lot of this yesterday. Want to finish this today. I think it's a good way to kick off January is to guys this hands-on project. All right, so I hope I have some time at the end of class because if I do, I want to get you guys started on, well, I could take you guys through some of these purple banner notes. I get you guys started on maybe torque, rotational inertia, that sort of thing. Um, I did give you guys this page on your this is on your desk, so you guys can take this. These are your uh, college physics textbook puzzles that we're eventually going to go through. But at least you can start to read those, get the idea of some of the questions headed your way. All right. Of course, I'm not going to be here tomorrow for jury duty. So here's the plan for tomorrow. I was looking at AP Classroom. You guys know those daily videos in AP Classroom, and so I think that would actually be a good use of your time because they have a good presentation. I went through a bunch of it. I mean, they have like days and days of videos on the stuff. So I went through and said, okay, well, what are ones that are, I think, like really especially good. Here, let me show you guys what I got posted. Got it pull up here. Here we go. So this is going to be by AP's book, units 5 and 6. All right, so what I got here? All right, notice it starts at 5.3. Now 5.1 and 5.2 is maybe I should assign those. Those are you guys remember turntable physics, rotational kinematics, and then how that connects back to linear motion. That's 5.1 and 5.2. If you need a review on turntable physics, then maybe I recommend you go watch that. But otherwise, if you hop in at 5.3, they start talking about torque and rotational inertia, right? All right, so notice I did skip a few in the middle here, which are all good. These are all good, even the ones that I skipped and didn't like explicitly assign here. But if you need more details, you can go watch the ones that I didn't post here. Right? But I wanted to post the ones that okay, I think this is like essentially good for the time that you're going to be here for. All right, now, actually, if you really the only way to watch all these in one class period is to watch them at 1.5 times speed, which I recommend anyway, because I think they talk kind of slowly. I think they do that on purpose, right? And maybe you prefer to watch them at regular speed. You could if you need to, right? But I'm going to really recommend that you watch them at 1.5 times speed. Do you guys maybe have earbuds or something? Because I'm trying to figure out 100% exactly how this is going to work, right? Like if you have your own laptop, you guys could bring your laptops tomorrow, right? That's how you're going to watch these. If you have your own earbuds, then you can watch them at your own pace, which is probably the best way to do it. If you guys wanted to do something like have one laptop per group, maybe if the sound didn't bleed through the room, I bet you guys can figure that out, right? Right. But if you have some earbuds, that's probably the best way to go, right? And what I really want you guys to do is, as you're going through watching these videos, see how do these ideas connect to these purple banner notes? How does right? What matches what? If you guys have this AP equation bank, you're looking at the equations over here. Here's your rotational dynamics, right? So you can see, okay, what's what goes where, what ideas are being introduced. Okay. Right, and then maybe at the end of class today, I can start looking at the subject. All right, so there's a setup, what we're going into, what's going on tomorrow. All right, you guys have these projects out. Okay, all right, you guys all good on this front, ready to go. All right, so let's finish this off here. We're trying to create this Geneva Drive. Actually, let me pull up the model here. Got this model. All right, so this is what we're aiming for. I got these two gears, again, like this, one with pegs, one with teeth. Okay. Right. And if you kept pace with me, then this is what you should have so far. Okay. I got one gear that I cut the teeth in at the very end of class yesterday. I think it's the last thing I did. Okay. One gear that I'm going to glue some pegs on. I got a bunch of pegs. So I had some squares, rolled them into cylinders, glued them, cut some feet so I can get a nice surface connection, which glues a lot faster. I also have a couple of axles. Right. Now, if you did exactly what I did yesterday, do you guys see how, like this? One of these axle systems, say the one in my right hand, I cut the feet a little bit longer. Therefore, the cylinder itself stands a little bit shorter. You guys see these are two different heights. You see that? Right. And the reason for that is that when I glue these down and glue these on top of them, Remember, I want there to be a small height differential so that, say, the pegged wheel sits a little bit shorter than the tooth wheel. Is it? Right. So the pegs can come up from underneath. All right, so that's a review. You guys saw that yesterday, just to recap. Okay. Here's a little detail. I don't know if this matters, but I kind of realized halfway through yesterday that with these cut pieces, there's a scrap left over that maybe looks like this if you cut it just right. This could actually be the baseboard. So I think in the official video I posted yesterday, I'm actually going to use the scrap as the baseboard. Therefore, you can actually do this whole thing with one page, but it doesn't really matter all that. Okay. If you guys need an extra page, that's all right. Okay. There's some extra materials on your classes or on your desk. All right, so how are we going to put this together? All right, we're going to glue, see, these pegs onto this wheel I haven't done anything with yet. Okay, so maybe I want 3 pegs and a handle in the middle, right, to match my model. Okay, really don't need 3 pegs. Yeah, 1 or 2, that's all right. Let's make my match the model. Why not? Uphill. Okay, 1 right at the middle to act as a handle. I've got that center dot right there. All right, so press that down. Okay. Okay. Now, these pegs, really to make this work, you only need 1. Now, if you only glue down 1, that's fine, as long as it works. Kind of the disadvantage of only having 1 peg, though, is the practical consideration that it's kind of off balance, right? Like it's not weighted. Like the center mass is not right at the center. Okay. And the fact the center mass is not right at the center and this is made out of physical materials, maybe this kind of wants to lean or get kind of wonky or warped or it's not set quite right. Okay. Okay. So from that point of view, if you did put on 2 pegs, you'd want to put them on opposite side. That could restore balance. Like the center mass would now be right at the geometric center. Okay. So that might be nice. I'm going to go ahead and do 3 to match my model. Now if I do 3, but you guys can solve this. Because if I have 3 pegs, what should be the angular displacement between any 2 adjacent pegs? 120 degrees. Yeah. So if you guys have protractors, maybe I could measure that and get that exactly right. Like if these are all the same mass and they're all spaced evenly, then the center mass of this whole disk should realign right to the center, which would be a nice feature. And so can make this 120 degrees. Oops, slide this a little. Well, actually, no, actually that is about where that goes. Yeah, that's right there. Okay, let me glue that one first. Point, throw a little dot, or maybe you can make a mark with your pen or pencil, like where exactly this is supposed to go. Okay, put it right here. All right, double check with my protractor, make sure that's 120 degrees. That's point. Yeah, I think that's right about where that needs to go. All right, and then this last peg, all right, kind of same story. All right, you need 120 degrees from that. Now, I'll mark this. It should mark this, right? 220 looks like right about there, I think. All right, does that work? 120 from the other one? 120. Yeah, that looks like the same spot. All right, that's where I want to put the last peg. All right. So if you got this perfectly right, then um, this may be a practical application of something you got to see student like center mass and what are applications of center mass. Okay? Is if this is really nicely geometrically balanced, then I should be able to balance this on my finger right at the geometric center because that would also match the center of mass. Ah, there it is. Okay. Okay. So if I turn this upside down, it's balanced like right at the center. Right. So it's really nicely balanced. Right? That's what I'm looking for there. Right. It's like if I only unglued on one of these pegs, or if I glued on these asymmetrically, then it wouldn't balance out the center. Right. And that'd be like, right. All right. All right. So here we go. Um, get real close here. Maybe these axles. Here's what I should do. Because I got to glue the top halves of these axle systems to the underside of these wheels and the bottom halves to the base. I think I'll save that bit for last. Right, so let's do this. I'm gonna glue the top halves of these axle systems to the bottoms of these wheels. Right. I want this to be right at the center. And I've got a central dot that's already marked from yesterday. So I'll just glue that right there. Boink. All right. Throwing a little more glue here. Get that to work any better. That'll be pretty good. Oh yeah, look at that. It's balanced. Balanced right there. Okay. Okay. Same story for this one. Here's the top half of this axle. Yeah, that'll fit in right there. Okay. So kind of same story. Let's see this dot through the paper that I put down yesterday. That's the very center of that circle. Yeah, right there. Ooh. All right. Look at it from the side. See like that handle on top and the axle piece on the bottom. Yeah, they are aligned. Pretty dang close. That's about it. All right, pretty good here. All right, so I'm gonna pop this axle back together on the bottom side. Right, remember that's able to rotate. Right, you guys remember this from yesterday? Like this can rotate like this. Right, so if you're keeping pace with me, then maybe you're about at this point. Right, and if you're a little behind that, that's all right. So you're looking to get up to this point at some point. Right, you guys do this. Right, right, same thing. Oops, that back together. Same thing on this other one. Let's get this here. Yeah, right. So that looks pretty good right there. Point. I'll rotate. Okay. All right. Now there's one more critical detail I have to get correct, which is the optimal spacing between the two axes. Okay. So I got my hands on the bases of the axes. I can slide them closer or further away. Okay. Now if I glued them right there, then this whole thing would be pointless because they wouldn't even touch, right? So I could spin them on the right all day, would never move the tooth gear. Okay. If I glue them together right here, that might be too close together. Right? What I'm looking for here, if I break out my, if they're too close together and you have the gaps cut too deep, then it might even jam and not move at all. Okay. But what I'm looking for, the optimal spacing, here's my model, is so that as one peg leaves one gap, the next gap is exactly aligned to accept the next peg. Right? So like a little bit of a Venn diagram looking overlap, right? But it has to be like that optimal type spacing. Yeah, right. And so where can I put that? Okay. So maybe like, let's see, if this one moves this tooth here, this one is, see, like that would be a little too close. This is going to get jammed. So I wouldn't want to glue this together right here because that's a little too close. So I got to move this a little further away. Point. Let's try that right here. It's just a few millimeters, right? And even that's probably still a little too close. So let's do a few more millimeters. All right, we're talking about like millimeters here. Ooh, okay. I think I have to warp this a little bit. Maybe move these teeth up a little bit. Right. I wonder if it could have helped if I put a little bit more height differential between these two. I don't know. Maybe I just spin up the teeth. I think that'll solve it. Okay. Actually, that's a little too far away. Okay. Okay, what I'll do is I'll glue one in place and then I'll slide the other one exactly where it needs to go. Base of an axle. Got there. Okay. All right. Now, this other one I'll put the glue on, but I gotta move it into place relatively quickly. Right. So like before the glue sets, I want to make sure that it's going to be in exactly the right place. I might have to slide it around a little bit. Right. Or another version is you could get it set right before you glue it, before you put the glue on, and then mark it with a pen or a pencil. Right. Maybe a good way to do it too. Let me see if I try it this way. Okay. So let's see, as that peg leaves that gap, the next gap takes up the next peg. Okay. Another way you can fix this too is if you have to cut the gaps in the teeth a little bit wider, you can, right? Like I could shave that down a little bit if I had to. I think that's about what I'm looking for right there. See if I can get this to go all the way around. That's looking pretty good. A little tiny bit closer. Yeah, all right. I think that does it right there. Yeah, it's going all the way around. Oh, yeah, sure. All right. So, okay, walk around, see how you guys are doing here. Actually, you know what? Maybe I'll close down this part of the video and then hop back in later with some notes.